Hello, everybody. Thanks for coming to this presentation. So this is a story of introducing a functional programming language, which is Scala, into a very big engineering and tech company, so very big like Criteo. So if you don't know Criteo, because a lot of people don't really know Criteo, because we are mainly a B2B company, we are dealing with a lot of other company, but not so much with individual. We are a very big company in terms of business, because we are displaying more than 3 billion of ads every day, and to do that, of course, we need to answer a lot of bid requests and to log tons of events across all the users on the internet. So we have to deal with a lot of data. I mean, really a lot. Like, we are logging more than 500 billion of events every day, events coming from all our partners. So this is I'm working in the data engineering group here at Criteo, which is called Data Reliability Engineering. And just to give you an idea of the size of the data we have to deal with, we have a giant Hadoop cluster, and we manage like 100 petabytes of data on this cluster. We have to run hundreds of thousands of jobs every day. So these jobs are mainly MapReduce jobs, but we have also Spark jobs. And the size of engineering is pretty big, mainly in Paris, but you have another office in France, in Grenoble, and 2 offices in the US. So we are more than 500 now, I think even more than 600. And we have a lot of analysts too, so because we are dealing with data, our main clients are analysts, and so we have a few hundred of analysts that need to use our data as well. So scalability and performance, by the way, are really concerned here at Criteo. So in a such big company with tons of great engineers, when you want to start introducing a functional programming language, let's say Scala, a lot of people are wondering if it's really a good idea. So there is many concern with functional programming language. There is many concern with Scala. Many of them are about performance. So, functional programming language is about immutability, immutable data structure, stuff like that. And of course, in terms of performance, when you are dealing with so much data, so much request every day as Criteo, a lot of people are concerned about the performance of this pattern applied to the company of the size of Criteo. And of course, about the culture as well, and readability of your code, and is it able to hire new engineers that will understand this code, and it will be easy to maintain in the long run. And so a lot of good questions, right? Because we are not, Scala is becoming a bit mainstream, but functional programming language in general are still not mainstream. So just to give you an idea, so we have a lot of very, very good engineers at Criteo. When we hire people, we ensure that they are very good at programming, very good at algorithm, very good at dealing with big data stuff and algorithm and fast algorithm. So this is typically the kind of interview question we ask. So that's not too difficult, that's classical problem. So this one, for example, is finding anagram in a list of string, and the classical solution is pretty well known for any good engineer. So you basically use an hash map as a data structure to organize the string in bucket and stuff like that. So that's the typical question, and that's the typical solution someone at Criteo will expect, right? With very, very good performance, but you see that the way you solve the solution is very imperative. It's very about telling the computer what to do, how to do it at a very low level. And as a functional programmer, the same solution, the solution for the same problem will be something like that. So it depends of your background, of course, but in my opinion, it's easier to read. But still, if you are not used to read this kind of code, you can find it very suspicious. So how can you do the same algorithm in so few line of code? What about performance? What is hidden behind the wood, behind the flat map? What does flat map means, right? A lot of people have very good concern when they see this kind of code. When you know what is behind this code, you know that it has the same complexity runtime, for example, as the previous solution. So you know that, but at first it looks very strange. So you can't really, in a company, any big company actually, so I'm not talking only about Criteo, but any big tech company, a lot of people come with a very imperative background, coming from C++, Java. They are used to create very low-level code and very performant code. So it's difficult to push this kind of new paradigm and new way of programming into such big company. Historically, Criteo is a .NET shop, right? So the founder all came from Microsoft, and since the beginning, we were all programming on the .NET platform and mainly using C#. And we scaled our systems across many data centers across the world, so the C# code base became very, very big. And of course, and on the .NET platform, you have F#. So if you don't know, F# is basically a part of OCaml to the .NET platform. And so you can do some very nice functional programming on .NET as well, but it's not very mainstream. And especially at the beginning of Criteo, it was not mainstream at all. But something happened at Criteo. We had so much data at some point, so because we are a Microsoft client, we are using SQL Server a lot, and we are still using SQL Server a lot to store all our data for OLTP workload. But at some point, for any analytics needs and any lab queries, it was not possible to store this data in SQL Server anymore. Even with sharding, even with scaling our cluster, and we scale our cluster to very, very big size. But it was not possible because sometimes, especially on the analytics, even if you want to shard it, sometimes you want to run query across like all your client or all your country, kind of analytics query. And so you need to have all your data in one place. And at some point, someone at Criteo started to introduce Hadoop and Hive because it was a way to deal with this size of data. And we became a user of the Hadoop platform. We now have a very, very big Hadoop cluster. And so with this Hadoop cluster, we had to change a bit our technology foundation because everything running on .NET and C# on Windows Server. And Hadoop, of course, everything is running on Linux, on the JVM, and mainly on Java. I mean, Java is the main language for Hadoop. So people had to start doing something else, writing some Java, using the JVM, using Linux. And so quickly, writing some MapReduce job using Java directly is not fun, so we started using a framework to create big data jobs, so mainly cascading at the time. So cascading is a framework to ease writing MapReduce jobs in Java. But then cascading was not fun enough, and Twitter came with this scalding project, which is a Scala wrapper to cascading. So it removed a lot of boilerplates, and writing a job in scalding is way better than writing them in cascading. And so we started adopting more and more projects from Twitter. And Scala project from Twitter. So Twitter is a Scala shop since almost the beginning, and they produce everything in open source, and we have almost the same concern as Twitter in terms of performance, in terms of scalability. So we started to adopt a lot of the Twitter project. Scalding, everything related to big data, so they have stuff like Algebird. And as we started using Scala for big data, we needed to create some tooling around big data. So I don't know, scheduler, framework, monitoring. So we had to create a non-core big data stuff, but basic application development. And we started to do them in Scala as well because we had Linux server and everything, and it was much easier for the team to write Scala. So we started to use Scala for application development as well. And we started using Twitter library as well. So Twitter has a very nice library. One is Twitter Util, containing a lot of stuff for Scala. They had Future implementation way before we had Future in the standard library of Scala. So it came with a lot of stuff, and it was used very useful for Criteo to scale our business. And so it's what we call Scava. So it's kind of a mix of Scala with some Java pattern apply. So you don't really know. You come from an imperative background, from C#. You move to Java. C# to Java is kind of easy. You find almost the same pattern, the same design, and then you have to deal with Scala. But you don't really know how to do this Java to Scala transition. And Scala is both a functional programming language, but it's still an object-oriented language. So you can still apply your old pattern to Scala, and it works, right? You can still do inheritance, you can still do mutability, imperative programming. And so you have a long transition when you move a big engineering team from Java to Scala, a big transition where people start using some Scala feature, but are mainly writing some Java disguise in Scala. So mainly imperative code, but in Scala. But this first step is needed for any company. Moving to more and more functional programming and more Scala. And it allows to hire more people, because as soon as you have a bit of Scala in your code base, you start hiring more Scala developer. You start telling the world that you are using Scala, doing conference. People are more and more interested about functional programming pattern practices. They try to go to conference to learn to speak. And then we were able to hire more and more developer having a bit of functional programming background. So they came with good idea, with a real background, with some very important knowledge, and we could apply to Criteo to scale our knowledge of programming, functional programming. And at some point, we moved to some Scava code, so mainly imperative code and mutable code, and but written in Scala, to very good functional programming pattern and Scala code. And today we are using a lot of library from the type level community. So if you don't know type level, they are producing a lot of very good functional programming library. For example, Doobie to access a database using SQL, Circe to deal with JSON, Cats is a kind of a second standard library, FS2 is for streaming. So this library push a very good very high quality project, and we started using them, and it's nice for us. People usually like, for example, they like Doobie. So Doobie is very functional, very functional library. It uses a free monad pattern. Everything is lazy. But as a user, you don't really see that. So it's kind of easy for a user to start using it. And as soon as you start Doobie, you get Cats, by the way, because it's a dependency. You don't see it, but you get Cats. At some point, you start using Cats because you discover all the goodness of Cats. And then you have to deal with JSON, and you are looking for a JSON library in the same space, and you find Circe, and you start having very good functional programming library in your class path. But there is a few problems anyway. So the first one, when you are moving from imperative programming to functional programming, is mainly the tooling. So the tooling for developer is mainly built for imperative programmer. First, you have the IDE, and the IDE is very important to any developer because it's a productivity tool. But the IDE are done for imperative language like C# or Java. You have a step-by-step debugger, you have all this kind of stuff that does not really apply well to functional programming, or where everything is lazy, and it's a different pattern. So as a developer, when you do the switch and you keep the same tool, because for example, you were using IntelliJ for Java, and then you have IntelliJ for Scala, so it's fine. It looks like, okay, I can still use the same tools. But when you try to apply it to your real code development, you have a bunch of problems. Suddenly, some of your code is not compiled, some recognized by the IDE, so you have some red mark everywhere in the code. It's not because your code is wrong, it's because the IDE does not understand your code, but your code is still okay. So it's strange for any developer coming from Java, for example. And then you use the debugger. The debugger is very difficult to use because, yeah, it's step by step, everything is mutated in place, and then you are evaluating some Scala code, and nothing is changed in place. Step by step doesn't help because there is lazy evaluation and stuff like that. So at the beginning, it's very difficult for people to keep the same tool and to apply them to Scala. Same for the build. So we are using a build pipeline based on Maven, and you can still use Maven for Scala, but it's not really idiomatic, right? You don't have the cross build pattern built in Maven, for example. So at first we didn't want to deal with cross-build. But at some point you have to deal with cross-build because when you have such a giant code base and we want to move to Scala 2.10 to Scala 2.12, it becomes very difficult to do it in a one big step. You want to do it incrementally, and then you need to introduce cross-build. So all this tooling, build, IGE, debugger, code coverage, you have the feelings that you can move from Java to Scala and keep the same tool, but it's not totally right. You can, but it won't help you to adopt the right practices of Scala. The second issue we have is that there is basically two worlds in Scala. There is Scala for application development and Scala for big data, and that's very different. So Scala is a very important language in big data processing because you have a lot of framework based on Scala. You have Spark, you have Scalding, you have all this framework, but it's very different. It's different concern. For example, when you are writing an application in Scala and you want to deal with JSON, what you will favor is the robustness of your program. You will try to pick a very good Scala JSON libraries that doesn't give you null, for example, that allow you to create a nice encoder, decoder, and that's nice. But when you are, for example, dealing with JSON on a big data cluster, what you want is performance, especially if you are going to parse 1 billion of rows of JSON. You don't really care if you have the best abstraction to deal with JSON. What you want is performance, right? Even if your library gives you null everywhere, it's fine because you don't want to lose some CPU cycle to deal with stuff you don't care. And so that's basically two worlds. You have, for example, CATS for application development. You have algebra, but if you are working with a Spark, you will deal with stuff like algebra, for example. And when I'm creating a Scala program, as soon as it compiles, usually I'm fine. I know that if it's compiled, it will probably run, or I'm close to have it running properly. But on big data, it's very different because the set of concern you express in the type system is not so important compared to all the surface of the I/O your program will deal with. A big data job is basically dealing with I/O everywhere, reading some data from file system, from the network, and writing from the network. And all this kind of stuff are not tested at all by your type system, by the Scala compiler. So you will have a lot of problem to make a big data job work properly on the cluster, even if it's compiling fine and you use the type library like Scalding or Spark. And the last issue is mainly to forget the old pattern you have. So you have the problem of tooling. So you try to apply the old tool to the new language, the new pattern. But you have also all the old pattern you had in Java. So for example, people are used to apply a dependency injection a lot to their code, and when they move to Scala, one of the first questions is how do I apply dependency injection to my Scala code? And if you know dependency dependency injection framework in Java or in C#, you know that they usually deal with mutability. So they try to put everything at null, and then a framework will magically set everything at bootstrap. And you don't want to do that in Scala. And it feels strange for people to just drop this kind of tool when they are starting writing Scala code. So there is a lot of practice you have to forget, but at the same time you really want to know what are the right practices, right? And Scala is a very complex language. You have so many features, and there is so many blog posts about all these great patterns, like the cake pattern, for example, to dealing with dependency injection. So, okay, I can't use a Spring anymore, or just, okay, let's see how to do that in Scala, and you will find the cake pattern blog post, and wow, that looks so cool, and you don't really understand what it is, right? It looks very complex, but you don't know, you are new in Scala. So try to apply it, and then suddenly your code base becomes very, very bloated. And you have to make this kind of mistake several times before knowing what to do and what are the right patterns to apply in Scala. And hopefully, when you are working in a team or in a company, it's much easier to share this kind of practices and knowledge in a company. So if you are alone or a very small company, it's difficult because you will make all the mistakes yourself. But if you are in a big company, the right thing to do is to share knowledge, to do some workshops, and to not replicate the same mistake done in one team in another team. Yeah, it was this slide actually. So yeah, that's all. So after a few years of writing some Scala, we can say that Criteo became a Scala shop too. So not all our code base is written in Scala, of course. We have a lot. Everything dealing with the core business is still using .NET and C#, and it's fine because one of the most difficult stuff we had to deal with .NET was basically Windows Server, but thanks to .NET Core, we are able to migrate all our code base and tools to Linux now, so we can, you can keep .NET and C# and run everything on Linux now, so it's more modern. And we are using Scala mainly for big data and all the tooling developed around big data. So we are developing a lot of internal tools, and we try to put as much as possible to GitHub, so to give back to the community, because we are using a lot of Scala library from the community. So for example, on our GitHub, you can browse the Criteo GitHub organization, and you will find a few projects. I will just list a few of them. So this one, for example, generates documentation from your Scala source code. So it takes the Scala, it's a compiler plugin. It takes your Scala code, and it will generate an HTML page with the code on the right, the commands formatted on the left, and it will style, colorize, and type all your Scala code in HTML directly. So, for example, when you hover your mouse on a value, you will find the type, and when you click on the value, you go to the documentation. So it's a very nice way to make documentation and to present code example that people can understand directly from your website or from your GitHub. Another project we released is Cuttle. So we had the demo yesterday. So if you were here yesterday, it's our job scheduler, and it's all written in Scala. It's a job executor and a job scheduler. You have a Scala API for everything, and it's totally open source. Yeah, it's a video. We released this project as well, which is our SLA board. So we have everything. We have a lot of this board on our TV screen on the engineering floor, but it allows us to track SLA for dataset, basically, or for any system you can extend it. It's just a Scala framework. We open it as well, so you can use it. And the last one I wanted to present is Babar. So Babar is probably useful for some of you. And I guess there is a presentation this afternoon of Babar. It's a monitoring tool to extract a lot of information about CPU, memory, and stuff like that for your Hadoop cluster. So it will gather all this information for all your distributed jobs and allow you to draw this kind of flam graph or other interesting metrics and visualization that can help you to improve your jobs. And yeah, and that's all. Thank you.